Okay, let's see if this is working properly. We're not going to start on question 17. We're going to start on question 1. So let's check this out. This is 6th grade post-course detailed answers. We're going to start with page 1. Page 1, question 1 says write 13 times 13 times 13 times 13 times 13 times 13 as a power. So when we write it in exponential form is really the better term for it, is we're going to take the number that is being multiplied repeatedly. We call that the base. So this is the base, and we see that it's being multiplied 1, 2, 3, 4, 5, 6 times. So 6 would be the exponent. So in a question like this is a very, very basic form, and most students get this question correctly. The tricky part is when they do something like this. 1/2 times 1/2 times 1/2. This time the base is 1/2, but the mistake that students make is they write it in this manner. That's not what that says. What this equates to is 1 times 1 times 1 over 2. That exponent has a base of 1. Why didn't we include the 2? Because there are no parentheses. So we have to be very careful about that. So this is actually written with parentheses, and that means it's inclusive. So we want 1/2. This is the exponent is 3, but the base is 1/2. So when we want to include the 1 and the 2 together, we have to include parentheses. You will also see in the more advanced question is this. When we have the other place that students make mistakes is when we have -4 times -4 times -4 times -4. We can't write -4 to the 4th. That's incorrect, because this really means the opposite of 4 to the 4th. So that's not what we want. We don't want 4 times 4 times 4. We're not multiplying 4 times itself 4 times. We're multiplying -4. So this is equal to that. So again, we have this situation where you need parentheses. So there's a big difference between those three. So if we ever see -2 to the 3rd, we need to understand that the exponent is 3, but the base is 2. And then this negative is outside of it. This is the opposite of 2 to the 3rd. Well, the way we would write the opposite of 2 to the 3rd would be that. And then if we see something like -5 to the 5th, well, that's going to equal -5 times -5 times -5 times -5 times -5. The 5 being the exponent and the base being -5. So you see 1, 2, 3, 4, 5. That is my base times itself 5 times. So the proper easy question is this. And again, as I say, most students get this question correct. They struggle later on in algebra when it's a little bit more technical. So we have to be careful about the difference of writing these exponential notations or forms. Find the value of 5 to the 5th, okay? So we have the exponent is 5, the base is 5 also, so that is going to equal 5 times 5 times 5 times 5 times 5. We know that 5 times 5 is 25. We know that 5 times 5 is 25, and then we bring down that 5. 25 times 25 is 625. That doesn't sound right, but we'll see. Let's do 25 times 25. Where's my calculator? 25 times 25. 625. And then we have times 5. With what? Sorry, that's not correct. That is 5. That's 2. That's 31. 3125. I think that is correct. So let's do 625 times 5 gives me 300 or 3,125. Okay. So here, and there's nothing technical about that. That's pretty easy. We should know how to expand those. This is orders of operations. Order of operations goes grouping symbols, exponents, multiplication and division. We're going to do that left to right, whatever comes left to right. And then we have addition and subtraction. So we have grouping symbols as our first step, and we have grouping symbols here. Well, those that didn't work very well. Grouping, no, that's not going to go very well. Okay, so let's use a different pen. So here are grouping symbols. So we're going to simplify inside there. There's only one operation, so we're going to do 7 minus 9 times, that's still multiplication between the 9 and the parentheses. 17 plus 7 is 24 divided by 6 squared. So there are no more grouping symbols. This is not a grouping symbol anymore. This is not grouping. There's no operations inside there. So this is just showing multiplication. So our next operation is going to be exponents. And we have an exponent right here. So we will simplify this. The base of that exponent is 6. So we have 7 minus 9 times 24 divided by 6 squared is going to be 36. That is, you should know your squares at this point. So perfect squares, we call them squares. And they're also known as perfect squares. So perfect squares are the products. So if you have 1 squared, 2 squared, 3 squared, 4 squared, 5, 6, 7. Let's keep going down here. 8, 9, 10, 11, 12, 13, 14, 15. Reasonable. So 1 squared is 1 times 1, which equals 1. 2 squared is 2 times 2, which is 4. 9, 16, 25, 36, 49, 64, 81, 100, 121, that doesn't look like 100, let's make those 100, 121, 144, 169, 196, 15 is 225? I want to say 225. I should know that. Let's do 15 times 15. 225. Good. All right. Good job. Yeah, and that's reasonable. Every 8th grade student should know up to 15. Maybe up to 20 is reasonable. So the perfect squares. So these are something you really need to know. 1, 4, 9, 6, 25, 36. When we see those, we know that they are perfect squares, and that's going to come in when we start doing radicals or square roots, that we know that the square root of 81 equals 9. So we should know our squared values. All right, next one. So we have all the exponents done. Now we have multiplication and division. So let's do multiplication and division left and right. So we have multiplication and then division. So we're going to do the multiplication before the division. Now here's the crazy thing. Here's where students will make their next mistake. You have, what is that product? I'd love to know what you think you're going to multiply. What you're multiplying is -9 times 24. But Mr. Matt, that's a subtraction. It is. But just like Mr. McCausland is a teacher when he's at school, he can be a coach when he's out on the lacrosse field. He can also be a parent when he is downtown with his kids. So I wear many different hats, and it depends on what you're asking of me or where you see me. So in this situation, if we read this problem, that definitely says 7 minus 9 times 24 divided by 36. But when we break down the operation, we have negative 9 times 24. So this ends up being 7. What's negative 9 times 24? You have, well, let's not do negative. Let's do 24 times 9, which is 36, 18, 21, 216, and we have a negative times positive, so that's negative 216 divided by 36. Okay? So that's very important for us to be able to understand what we're multiplying. Next operation is going to be division. We're going to divide negative 216 divided by 36. So one of the ways that we can do this without a calculator is, first of all, we know that 9 times 24 gave us a 216. 9 times 24 gave us that 216 divided by 36. That's the same way of writing 216 divided by 36. Now, yes, this is negative, but we'll just keep the negative out of the problem for the moment because that's not really part of the computation. So why did I not deal with this? I don't want to deal with this big number. I'd much rather deal with this broken down because I can cross cancel. I know that 9 goes into 36 4 times. And then I can cancel again because what goes into 4 and 24 is 6. So I know that negative 216 divided by 36 gives me negative 6. No calculator. It's just using logic, using our factors. And instead of making numbers bigger, I'm going to break them down into more manageable numbers. And 7 minus 6 gives me 1, which would be my answer for number 3. Lots of information there, lots of tricks, lots of techniques in order for you to be successful. Alrighty, let's look at number 4, GFC. So when we deal with GFC's greatest common factors, we're looking for factors. Those are numbers that are divisible into 56 and 88. So we use prime factorization. I do, and I find it very easy. So we can break this into its prime factors. So 2 goes into 56. That's going to go in 28 times. 2 is a prime number, so I'm going to circle it. 28 can be 4 and 7. 7 is a prime number, so I can't break that down. 4 is not a prime number, so I can break it down to 2 times 2. So my prime factors of 56 are 2 times 2 times 2 times 7. I'm always going to put them in numerical order. 88, we can do 8 and 11. 11's prime, so we circle it. 8 can be 2 and 4. 2's prime. 4 we can break down to 2 and 2. So 88 is going to be broken into 2 times 2 times 2 times 11. That would be the prime factorization. Now we're looking for the GCF. C stands for circle. Reminds me to circle the common. Okay, so when we look at the prime factorization, we want to circle what they have in common. They have a 2 in common. They have a second 2 in common. And they have a third 2 in common. Okay, so my GFC is going to be 8. 8 is the largest number that goes into 56 and 88. That is the most accurate, most confident method that I know of, that I've always taught on finding the GFC. Sound good? The next question deals with LCM. So least common multiple. Now we're dealing with multiples. Multiples of 12 or 12, 24, 36, etc. 9, 18, 27. So we again are going to find the prime factorization of these two numbers. So prime factorization of 12 is 2 times 2 times 3. 9's prime factorization is 3 times 3. Now, we're looking for the LCM. Remember, C stood for circle what they have in common. Okay, let's circle what they have in common. So they have a 3 in common. That's all they have in common. Now the second part of LCM is, L is leftovers. So we're going to circle what they have left over. They have a 2 left over. They have a second 2 left over. And then they have a 3 left over. So remember, step 1 is circle what they have in common. They have a 3 in common. And then circle what they have left over. A 2, a 2, and a 3. And if we add all those up, that's going to be 9 times 4, or 36. 36 is going to be the least common multiple between those two numbers. Very, very efficient. Very, very easy, as long as you remember the mnemonic memory aids that we put in there. So the LCM of those two numbers, 12 and 9, is 36. A mug is 1/5 full. Mr. Mack is a drawer. I love drawing. I'm more of a visual learner. So this is going to be 1/5 of the mug is full. The mug contains 3/8 of a cup of water. Find the capacity of the mug. Write the answer as a fraction or mixed number in simplest form. Okay, the mug is 1/5 full, and the mug contains 3/8 of a cup of water. Find the capacity of the mug. So, if 1/5 of the mug equals 3/8, we can write that statement. That's pretty good, right? 1/5 of the total equals 3/8 of a cup of water. So, I'm going to multiply by the reciprocal. Coefficient of n, we want to get n by itself. It's being multiplied by 1/5. The inverse of multiplying can be dividing, but it can also be multiplying by the reciprocal. Very efficient way. So we get n equals 15/8, and we can leave it as 15/8. Mr. Mack would leave it as 15/8 of a cup. Or you can convert it to a mixed number. In high school, most high schools will be working with improper fractions. There's nothing improper about improper fractions. Or you can convert it to a mixed number. That's not going to be any more correct. 15/8 is the same as 1 7/8. It's just converting. You're converting it into a different format. You're not simplifying. This is not simplifying a fraction. It's in its lowest form. There's no number that goes into 15/8. So that is simplified. That is in its lowest terms. When you turn it into a mixed number, you're just converting it to a different format, just like if you wrote it as a decimal. Number 7 says 1 3/4 divided by 1 1/6. Here's a great example of what high school would expect to be. You're not going to keep it in mixed numbers. Mixed numbers don't work. They're not very efficient in any manner. In high school, you will constantly deal with improper fractions. So, first step is to turn it to an improper fraction. 4 times 1 plus 3 gives us 7/4 divided by 6 times 1 plus 1 gives us 7/6. Now, there is no division, so we're going to convert this. I think Mrs. Poole says keep, change, flip. Keep, change, flip, I think is what she says. So you keep the left fraction, you change the division to multiplication, and you flip the right fraction. You take the reciprocal, and then Mr. Mack would add cancel, meaning we're going to cross cancel, and then combine. You're not going to combine and then reduce. You're going to always try to cross cancel prior. 2 goes into 4 and 6. So 2 goes into 4 2 times. 2 goes into 6 3 times. 7 and 7 have a common factor of 7. Goes in 1 1. So we just canceled, we cross-canceled, and now we're going to combine. Now we're going to do the multiplication. 1 times 3 is 3, 2 times 1 is 2, and that's my answer. If you want to give it as 1 and 1/2, that's fine. But Mr. Mac's going to leave it as 3/2 because this is an extra step. That is extra step, not needed. If I give you 100 improper fractions to convert to mixed numbers, you're not going to get 100 of them correct. If this is correct, if 3/2 is correct, and this is no more correct, you're just taking a risk by converting it to a mixed number. Not necessary, especially in high school. All right, number 8, evaluate 24.891 plus 6.588 minus 16.965. Write the answer as a decimal. All right, so orders of operations. I'm going to do the addition first, not because we like addition, because it came first left to right. So I'm going to add these two, 24.891, 6.588. When adding and subtracting, we do align the decimals. So we're adding, so 8 and 1 is 9, 8 and 8 is 16, 17, 13, 14, 11. So we get 31.479, and then we're going to, so this equals, this statement now becomes 31.479 minus 16.965. So we're going to subtract. We're still aligning decimals because we're adding and subtracting. So we're going to subtract those. 5 from 9, 6 from 7. We got to borrow. So 9 from 14 is 5. Decimal point, can't take 6 from 0, so we got to borrow again. 6 from 10 is 4. 1 from 2 is 1. So my final answer is 14.514 is my final solution. Number 9, now we're multiplying. So when we multiply, we don't have to align. There's no aligning necessary, and it doesn't matter which one you put in the top or bottom. It really doesn't matter. I'm just putting those two numbers. We need to understand that 6.81 times 8.82 is exactly like 681 times 882. We're going to get the same exact digits in our answer. The only difference is going to be where that decimal place goes. Okay, and I'm going to show you real quick. We're going to do it. Watch this, 6.81. We're not going to use a calculator, but I'm just showing you an example, times 8.82. We look at those digits, 60, 0642. If I take 681 times 882, you'll notice that you get the same 6 digits, 60, 0642. And that's what we need to understand, that decimals do not make problems harder. It's the same numbers that you're multiplying. 2 times 1 is 2. 2 times 8 is 16, carry. 2 times 6 is 12, plus 1 is 13. We're going to move over a decimal place, or a place value, so we put an X. We're going to erase that top. 8 times 1 is 8. 8 times 8 is 64. 6 times 8 is 48. Plus 6 gives me 48, 54. We're going to move over another place to my other 8, and we're going to get the same digits as 8, 4, 4, 5. 8, 4, 4, 5. Okay, because we're multiplying the same number to the same 3 digits. So that's not going to change anything. Okay, so that's easy efficiency. So we're going to add these. These x's represent zeros. So 2 plus 0 is 2. 6, 12, 14. We got 8 and 8 is 16. We got 8 and 2 is 10. We got 10. We got 6. Now, how do we deal? And there's my 6 digits, 600642. So I'm counting the decimal places. We have 1, 2 decimal places, 3, 4 decimal places. So we're going to start here, and we're going to move over 1, 2, 0.34, and that's where the decimal place will leave itself. So it is, my final answer is 60.0642. All right, so that's the efficient way, that's the best way to write or to multiply decimals. Number 10, you make 12 equal payments. You pay a total of $2,148. How much is each payment? Well, we have to take that payment, 2148, and we're going to divide it into 12. So 12 doesn't go into 2, so we're going to take 2 places. 12 goes into 21 one time. So we're going to subtract that. 12 from 21 gives us 9. And now we bring down a digit, 94. 12 goes into 94. How many times? Well, 7. 7 times? Let's see. What's 7 times 12 is 84. Right? 7, 14. Yep. And we're going to subtract. That's 10. We're going to bring down that 8. And 12 goes into 9. 12 times 9 is 108. Usually with 0 left over. So how much is each payment? And it's a word problem, so we're going to write each payment. I'm going to write a word answer is $179. Notice where the dollar sign goes. Even though we say $179, the word dollar comes after the number. When notating and writing money, the dollar sign starts off. That allows us to know that we're talking about money. You do not write $179 sign. This is wrong. I see way too many kids writing that in 2025. Okay, so that's a nice way of doing that. Let's see, the next problem is going to be number 11. Find 2,705 divided 250. Right, the answer is a mixed number in simplest form. Okay, so this example, they do want us. So if it's stated, write it as a mixed number, then write it as a mixed number. If it doesn't state it, then don't. We have 2,705 divided by 250. So 250 goes on the outside. 2,705 will be on the inside. We're not going to go into decimals because they want it as a mixed number. So 250 doesn't go into 2, doesn't go into 27. It does go into 270. And it goes one time. So 250 subtract leaves you with 205. Now 250 doesn't go into 205, so you put a 0 there. That's probably the tricky part. This is your remainder, so it's 205 over your divisor. So that's how we turn that into a mixed number. So your answer is 10,205 over 225. But it says it has to be in simplest form. So we know that fraction, we know that 5 goes into that. 5 goes into 205 41 times, and 5 goes into 225. It goes, what's that, 8, 9? No. It goes in 45 times. Hello. So as a mixed number, in lowest terms, that would be 10 and 41/45. Okay? We don't have to go to the decimal, but we did have to go to that. So that's a little bit tricky with that, showing that place value for the 0. Find 0.442 divided by 0.34. Write the answer as a decimal. Here we go again. So we have 0.442 over 0.34. There's a couple ways we can do this. This is good. So we have 0.34 divided by 0.442. And we're going to write our answer as a decimal. So this time we are going to move through that problem. First step is this has to be a whole number. So we have to move that decimal point 2 places. Well, if we move it on the bottom, we have to move it on the top 2 places. So our initial step is to rewrite this. And all we did was move it 2 places here and 2 places here, which makes it an equivalent fraction. You're multiplying it by 100 in the numerator and 100 in the denominator. So our new problem, equivalent problem, is 34 into 44.2. We're going to bring that decimal point up there. 34 doesn't go into 4, but it goes into 44 one time. And that's going to give us 1, 0. Bring down the 2. 34 goes into 102. Is it going to go 3 times? Is it? Yeah, it's going to go 3 times exactly. And it's 102. So my answer is going to be 1.3. My answer is 1.3 is my decimal answer. Okay? So these are all skills that you should have learned and mastered, I guess in sort of 5th, 6th, 7th grade. 8th grade, we're not dealing with these skills, or 6th grade, here we go. It's the 6th grade post-course detailed answer. So in 6th grade, you should be able to complete these types of problems. What is the ratio of butterflies to birds? So the key, you have to be very aware of this. This is the attention to detail. It is butterflies to birds. Let's do butterflies to birds. So we can write it as a ratio using a colon. So how many butterflies? So let's take a peek here. We have butterfly. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 butterflies. To how many birds? Birds are going to be 1, 2, 3, 4, 5, 6, 7. So to 7 birds. So we can write it as that, 9 to 7. You can write it 9 over 7, or you can write 9 to 7. Those are the 3 formats that you can write ratios as. All of them will be acceptable. This looks like the most of a ratio because it has a colon. This looks like a ratio because it has a 2. This looks like a fraction, but it's still a ratio, the numerator to the denominator. Number 14, a tape diagram represents the ratio of your monthly allowance to your friend's monthly allowance. The monthly allowance total is 156. How much is each allowance? Okay, so you and your friend, so you are 1, 2, 3, 4, 5, 6, 7. And then your friend, so this is you and your friend is 1, 2, 3, 4, 5, 6. So your friend is 6. And total, if the total, that's going to be 13. So you are 7/13 and he is 6/13 of the total. So we can find how much is each allowance. So you can say, hey, 7/13 of the total, 156, would be your allowance. And if we want to multiply that, I'm not going to multiply 7 times 156 and then divide it by 13. I'm going to start breaking 156 down. Okay, well, 2 goes into that. 2 times 78. Okay, and 78 I can break down to, that's over 1. So I'm going to do this, and 7/13 times 2. Let's break 78. 78 goes 2 times, what's that? 39. And now I see that 13, I know that 13 goes into 39 3 times. So that leaves me with 7 times 2 times 2 times 3. Or that's, what's that? 4 times 3 is 12 times 7 is 84. So my allowance is $84. And then I don't have to multiply this 6/13 by 156 anymore, because I know the total is 156. So I can just do 156 minus 84 to get my friends. And that's 2 and that is 72. So my friend has an allowance of 72, and if we add 84 and 72, you'll get 156. So my allowance is 84, my friend's allowance is $72. Like that? That's a good way of doing that problem. Number 15, a recipe uses 7 parts of milk for every 5 parts of sugar. Very important to notice that they're both in the same units. That's good. Complete the ratio table. How much sugar do you use? So here is our known. I call this our known. So we're going to use this when writing equivalencies. So 7/5 equals, this is situation 1. We have 14 to what? To x. Well, we have a couple ways of doing this. This is equivalent, so this is a multiple, 7 times 2. If we want them to be equivalent, then we have to multiply by the same proportion. So 5 times 2, so this is going to be 10. It's a nice way of doing that when they are proportional. I'm going to use my known on the next one. So 7/5 is equivalent to x over 15. We go from the known to the unknown, so times 3, so that's going to be 21. And the last one is 7/5 is my known equals 28 over x. Well, this one's another proportional one, 7 times 4, so that is 20. Okay, so 14 to 10, 21 to 15, and 28 to 20. That's a nice one. The other technique is cross product. You can cross multiply. If you have 7/5 equals 14 over x, we can multiply and multiply. So 7 times x equals 5 times 14, 7x. Well, I'm not going to multiply those. I'm just going to divide by 7. I'm going to show you that making it bigger. So that's 2. 5 times 2 is 10. That's cross product. Another good technique. Number 16, soup A has 8 grams of sodium in 10 cups. Soup B has 7 grams of sodium in 14 cups. That's good that we continue. Same units. Which soup has more sodium per cup? So sodium per cup. So we're going to do sodium 8 to 10, and we need a unit rate per cup. So this is per 10 cups. So I'm going to make this 1. So what do? We divide it by 10. We divide by 10. We get 8/10 grams per 1 cup. And that is going to be 0.8 grams per 1 cup. That is for soup A. Soup B, soup B, we're still in soup to cups, or sodium to cups. So we have 7 grams to 14 cups. And I don't want 14 cups, I want 1 cup. So we could divide by 14. Divide by 14, 7 divided by 14, hopefully you know is 0.5 grams to 1 cup. And we have 0.8 grams for 1 cup. Which soup has more sodium? Is going to be soup A. So let's write our answer. Word problem, word answer. Soup A has more sodium. Okay, soup A has more sodium. I want to see that work. Don't just write the answer. I'm going to want to know why you made that answer, and you have to do it with data. I'm going to, if you just write that, you're not going to get credit for an answer. I need to see, I'm going to be looking at your work, and I'm going to be looking for that 0.8 grams and that 0.5 grams. So very important that you show your work. All right, last problem on page 1. Represent the ratio relationship using a graph. Okay, so we have time and distance. So we're going to make a graph with 2 axes. You can have time on one, distance on the other. It doesn't really matter. but you should be labeling them. Increments should be the same too. So let's put time on the x-axis. Let's put distance on the y-axis. It does not matter, but we're going to have increments, and you're going to go, technically you see it's 10, 20, 30, 40, 5, 10, 15, 20. So time, we're going to do 5, 10, 15, 20, 25, 30, 35, 40. And distance is going to be 5, same increments, 10, 15, 20, 25. So 5, 10, 15, 20, 25. So time is 10, gives us a distance of 5, so we make a dot there. At time 20, we're going to have a distance of 10. At time 30, we're going to have a distance of 15. And time 40, we're going to have a distance of 20. So that should be a relatively straight line. We will not connect those. Now, if you did distance on your x-axis and time on your y-axis, then it would be a little bit more sharper going up. But this is absolutely. And then you can say, oftentimes we label the unit too, distance. Time is in, not miles, Mr. Mack. That would be interesting. In minutes, and distance is in miles. So writing that abbreviation there. And then you would write a heading, the relationship between distance and time, etc. That's it. Okay. Hopefully you did well on those problems. Maybe you learned something. Hopefully you learned something. If you got all 17 problems correct, that's a great job. You should feel confident in yourself. If there are issues that you see that you need to work on, address those issues over the summer and come into 8th grade being proficient at those weaknesses. Good luck.